Hi there. So I wanted to give a little update on this project I've been working on. This is a true first-person multiplayer shooter made in Unreal with Unreal's Gameplay Ability System, or GAS. So I'm going to go over some of the features and then talk about some of the blueprints and data assets and how everything's put together. So to start off with, as you can see, this is true first person, which basically means you can see the feet. The main difference between true first person and the more traditional first person setup is that in true first person, the camera is attached to the player mesh on the body. Whereas traditionally you would have a pair of floating arms kind of attached to a camera. The main reason I went with true first person is just as kind of a learning exercise to get more experience with this setup and some of the challenges that come along with it. So as you can see, we have some procedural animation happening right now. We have weapon sway, so as I turn the camera, the gun kind of sways back and forth. And we also have procedural footsteps, so as I run around, the gun bobs up and down, depending on the player's velocity. We also have aim down sights, or ADS, and recoil. So all of this animation is driven by code. We have several components on the gun, such as the recoil component, the weapon sway component. There's a footstep component where you can configure the settings and animation. This way each gun can have its own kind of feel. For example, if I switch over to the assault rifle, so the assault rifle actually has a recoil curve. So because it's automatic, as I fire, the gun will move up in kind of a recoil pattern that is defined by a curve. So as I hold fire, the gun should move up and to the left a little bit, which might be visible in the video. So this enables us to have guns with different weapon or different recoil patterns. So players can kind of learn the recoil pattern and learn to counteract it by pulling in the opposite direction. So then next we'll take a look at some of the ammo types. So this is where GAS really starts to come into play. Each ammo type is defined by a data asset for each different weapon. This makes it really easy to add new ammo types with different effects and different damage. And each ammo type has two damage gameplay effects. So there's a impact damage gameplay effect, which will be dealt to the target on projectile impact. And then there's an optional delayed damage effect, or secondary damage effect, which will be dealt after a certain duration. This allows us to do things like have incendiary ammo, where the projectile will deal some damage on impact, but then continue to deal damage over time with a secondary gameplay effect that has a duration. So I will demonstrate this in a moment. So here we have the standard ammo. We have armor piercing, incendiary, and explosive. So then if you look down in the right-hand corner, you can see we have 100 rounds, and the number on the right is how many rounds we have in the player's inventory, and the number on the left is how many are currently in the gun. So currently I have 0 in the gun. If I were to reload, we now have 30 rounds in the gun. And if I switch ammo types, so now we have armor piercing rounds. We have 30 armor piercing rounds in the gun. And in fact, if the player dies, they will drop the gun. So then another player could come along and pick this gun up, and there would still be 30 armor-piercing rounds in the gun. So to demonstrate, I'm actually going to switch over to the other character, or the other player. So this guy has a pistol, and I'm going to pick up all the different ammo types for the pistol. So if I fire, right now we have standard, just the standard ammo. And you'll see down in the left corner, it took a chunk out of the armor. So the armor is the blue bar, and then the health is the red bar underneath. And if I continued to fire, it would just continue taking out armor until it reaches health. But if I switch over to armor-piercing rounds, you'll see a portion of the damage gets applied to the armor, but then a portion of the damage makes it through. So this is actually determined by an attribute, the armor-piercing attribute. So ammo types not only have damage gameplay effects, they also have unequipped damage effects. So these are applied to the player who is currently holding the gun. In this case, the armor-piercing rounds apply a gameplay effect to the player holding the gun that increases their armor-piercing attribute. This attribute is then used in the execution calculation that's used to calculate damage when the projectile hits. So the projectile will deliver those gameplay effects to the target, and then the execution calculation will take into account the armor-piercing damage from the source, or the player who's firing the gun, as well as the health attribute and the armor attribute from the target, or the player who was hit. So then if I switch back over to this guy, I'm going to switch over to the incendiary rounds. So these are the ones that have, these ones have a secondary gameplay effect. So they will deal damage on impact, but they also have a damage over time effect. As you can see, the other player kind of starts on fire. And this effect stacks, so if you get hit by multiple incendiary rounds, you will receive more damage over time. So then if I switch over to the explosive rounds, so both the rifle and the pistol have explosive rounds that have a secondary effect, which basically the projectile will deal some damage on impact, it will stick to the target, and then after a short duration it will explode. So this is something like a bolter round from Warhammer 40k, or even kind of like a needler from Halo, as you can see. So then I'm going to come over here, and we have a couple other weapons. So we have the shotgun, so I'm going to pick up the shotgun. As you can see, we dropped the pistol. And the shotgun currently has two ammo types. We have just the standard ammo, and then we have explosive ammo. So the shotgun fires multiple projectiles in a cone. And actually, every weapon has weapon spread, which is determined by a weapon spread component on the gun. So it will fire the projectile randomly within that cone. So the projectile isn't just a straight line. And I can demonstrate that. I'll switch over to the assault rifle, and I actually have a console variable for weapon spread debug. So now, when I go into aim down sights, you'll see we have a cone, and when I aim down sights, the cone starts to shrink. So when you're aiming, the weapon will be more accurate than if you just hip fire. And if I go ahead and I'm going to switch over to the standard ammo type. If I go ahead and fire and hip fire, you'll see the cone kind of increases as we continue to fire. So it becomes less accurate as you continue to fire to encourage, short controlled bursts. This red line isn't the direction of the projectile. That's actually the original target vector. But if I were to reload and then go into aim down sights, you'll see it's much more accurate. But if I switch back over to the shotgun has a larger weapon spread just starting out, so it's less accurate, but it does fire multiple projectiles. And if I switch ammo types, so the shotgun also has an explosive ammo type, which is similar to the RPG. So I'll go pick up the RPG. So both the RPG and the shotgun deal explosive damage that is set to deal area of effect damage, essentially. So it will deal damage in a sphere within a certain radius to every target that is hit. I'm going to go ahead and turn off that weapon spread debug. So this way I can kind of hit next to the player and he'll still take some damage. Right now the damage is tuned way down just because I was playing around with it. But if I switch over to the shotgun, you'll see that's also dealing explosive damage. So both the RPG and the shotgun, their explosive ammo type also has a setting for rocket jumping. So we have rocket jumping enabled. So if I run forward, shoot at the ground, I will rocket jump. And this goes for the shotgun as well. And yeah, so that was just a kind of overview of some of the weapons and the ammo system in my game. Next, I'm going to switch over to the AI test map and show off some of the bots. See you there. All right, so here we are in my little AI test map. The first thing I did was mute the audio so that I don't have to talk over a bunch of gunfire. I'm also going to make my character invincible so that I don't die when I'm running around talking. And you'll see all these bots kind of immediately engage. The ones that can find cover will do so, and the ones that can't will strafe around and shoot. The way the cover system works is each piece of cover has multiple cover spots around it. When a bot is searching for cover, if it finds one that's available, it will then reserve it. It will then try and move to it, and when it reaches cover, it will claim it. Reservations last for a short duration, and bots cannot claim cover that has already been claimed by a different bot. They will try and find cover that's within kind of an ideal radius. In fact, I'll go ahead and turn on the cover debug. So you can see the yellow spheres indicate that it's reserved, and the green spheres indicate that it is claimed. So they try and find cover within kind of an ideal range. So if I move forward, one of them should probably try and claim this one. Maybe. Yep, there we go. So you can see he claimed it and then moved to it, and now, or he reserved it and then moved to it and then claimed it. So as he pops in and out of cover, if he leaves cover, he will reserve that cover temporarily. That way, another bot can't just swoop in and steal the cover whenever he pops out to shoot. However, if I were to, say, kill this guy, so now this cover spot opened up, and another bot can immediately claim it. And you'll see as I move around, they kind of reposition. They try and keep the cover in between themselves and me. If I get too close, they will leave cover and kind of start either try and find another piece of cover or strafe. So you'll see he's kind of strafing now. And the spot is reserved briefly. And yeah, so friendly fire is still on. They will try and avoid shooting at each other, but they're not always successful, especially with all the gunfire happening right now and bullet spread. So sometimes they will kill each other. But as I move around, you'll see this one kind of tries to keep the cover position between itself and me. They currently have infinite ammo on their person, but the guns do need to be reloaded. So if they need to reload, they'll try and find cover to do so. And yeah, so the main reason I went with a cover system like this instead of a more dynamic cover system based on terrain and EQS queries is this gives me a little bit more control over cover placement, and it also gives the illusion of coordination. So the way the cover's spread out, it kind of feels like the bots are talking to each other and coordinating, but they're not currently. It's just kind of a simulation. Another benefit is the cover can be set up to apply a gameplay effect. So say you have a really good piece of cover, you could add a gameplay effect that will be applied to the occupant that increases their armor, for example. Currently, none of these do that, but they are set up to do so if you so wish. All of the AI logic, including the cover system, is all kept within its own plugin. So that means theoretically I could take that and bring it over to a different project. It's all decoupled from this specific game's logic. All you have to do is add so the plugin is called the Puppet Master plugin. So all you have to do is add the Puppet Master component to your AI bots in a different game, and it should work. And yeah, so in the future, I would like to add some more behavior. I would like to add some more coordination. Right now, we just have this simulated cover coordination. I would like to add some actual communication, such as bots forming squads and talking to each other. If they see an enemy, they can all kind of warn the others. I'd also like to add pickups. So right now they do have infinite ammo in their inventory. I think it would be cool if they could run out and then they would have to go search for ammo, search for new weapons, or even health packs and stuff. But yeah, it's working pretty well so far. Next, I'm going to give a brief overview of some of the blueprints and data assets in my game. So I'll see you there. All right, so now I wanted to give a little tour of some of the blueprints and data assets that make up my game. I'm not going to go into any of the code, but I did want to give a kind of high-level overview of how everything is set up and organized. So most of the logic takes place on the C++ side. As you can see, this is the player character blueprint. The event graph is empty. But everything is very data-driven, which makes it easy to add new abilities, new ammo types, new weapons, and configure everything. So to start off, we'll take a look at the input config. So this is a data asset that's in charge of associating an input action with a gameplay tag. So for example, here we have the input action for aim down sights, which is just right click, which will be bound to the gameplay tag input tag aim down sights. And then if I head over to the gameplay ability for aim down sights, you can see up here is where we set the input tag that's associated with this gameplay ability. So essentially what happens is when that input action is fired, so when you right click, the input component will look for an available gameplay ability that matches that input tag, and if it finds one, it will try to activate it. This is set up very similar to Lyra. So then if I head back over to the player character, you can see this is where we set the default character, default gameplay abilities that are granted on spawn. So for example, we have the gameplay ability aim down sights. We also have the default attributes and default max attributes. So these are both applied as a gameplay effect on spawn. So we can take a look at those. And you can see these are just modifying the attributes. So setting health to 100, health regen, armor. And then we have max health and max armor. So the player also has a number of components. We can take a look at some of those. We have the weapon manager. So this is in charge of managing weapons, of keeping track of which weapons are currently equipped, which ones are held in inventory, how many weapons you can hold at once. So for example, right now we have it set to 2, so you can hold 2 weapons. We could increase that if we wanted to. We also have the default weapon loadout, which is just a data asset. So in this case, we have the rifle and the pistol will both be granted to the player on spawn. And the AI character also has a default weapon loadout. I think theirs is just set to a rifle right now. Yep, so the AI character just receives a rifle. We have the ammo manager. This is in charge of keeping track of the player character's inventory, ammo inventory, how much ammo you currently hold. We have the interaction component. So this is in charge of interactions with the world, with with objects in the world that are marked interactable. So for example, the weapons are interactable, the ammo is interactable when you go to pick it up. And if I head over to the rifle, you can see this has the interactable component right here. So this is what kind of flags this as something the player can interact with. And taking a look at the rifle, we have several components here. We have the weapon sway component. So this is in charge of that procedural weapon sway. We have different settings for both default and aiming. So when you aim down sights, you should ideally have less weapon sway than when you're just hip firing. We have the weapon spread component, which is similar. We have default weapon setting or default cone settings and aim cone settings. So this is what controls that weapon spread cone that we saw. And again, different settings for aim down sights so that you want to be more accurate when you're aiming down sights. We have the projectile weapon component. This is in charge of spawning projectiles. And here we can set the default projectile class and how many projectiles are fired. So actually, if I take a look at the shotgun over here, you can see right now the shotgun is set to fire 10 projectiles in a single shot, as opposed to 1, which is what the rifle fires. The ammo component, this is in charge of the ammo that's in the gun, as opposed to in the player's inventory. So this is where you can set which ammo types this gun can hold, as well as which ammo type it starts out with, and how much ammo it can hold. So the rifle can hold 30 rounds. And then we have the recoil component. This is in charge of recoil, all those configurable spring settings. And because this is the rifle, we also have the curve that dictates that recoil pattern. So then, let's see. I'm going to head over to some of the other. Let's head into the rifle stuff. So we have the gameplay effect for rifle equipped. So this is the gameplay effect that the rifle will grant the player when the player equips the rifle. So it's not super complex. Right now it just grants some tags to the actor. In this case, it grants the firing mode automatic tag. Uh, single shot weapons like the pistol will grant firing mode single shot, and that's used by the fire weapon gameplay ability to determine what type of firing mode we're in. So I can go into the ammo. So here we have all the different ammo types for the rifle. We have the pickup items, the blueprints. I can take a look at that. These are pretty simple. We just set the data asset that's associated with this, that this pickup grants, and how much ammo it will grant. And then if we go into the actual data assets themselves, this is where we can configure the ammo, so all the damage and the gameplay effects. So right now we're looking at the armor piercing ammo for the rifle. So you can see we have the weapon tag at the top. This is where we just set which weapon this ammo is associated with, which is used for mapping ammo to weapon type. We have the equipped effect class. So this is the gameplay effect that is applied to the player who is holding the gun when they equip this ammo. So for example, because this is armor piercing, this is the gameplay effect that will increase the armor piercing attribute. We can take a look at that. So yeah, so this gameplay effect will just set armor piercing to 50, modifying the player who is currently holding that weapon. So then we have two different damage configs. The impact damage config and then the delayed damage config. The armor piercing doesn't have anything under delayed, but it does have an impact damage config. So this is the weapon damage, generic weapon damage gameplay effect. And you can see we're dealing 10 damage per shot. So if I take a look at that gameplay effect, this is the weapon damage gameplay effect. Here's where we set the execution calculation that's in charge of calculating the damage dealt. And if we look at that one, you can see, so all of the calculation takes place in C++, but here we can set which attributes are captured. So for example, we capture the armor piercing attribute from the source, or the character who's firing the projectile, and we capture the armor from the target, or the character who is hit. And then that is used to calculate how much damage will be dealt in the end. So then, let's see, if we were looking at the armor piercing, if we were to then go over to the explosive, so this is that explosive ammo that's kind of like a bolt around from 40K, where it sticks to the target and then explodes after a short duration. So this one does have a delayed damage config. This one doesn't have an equipped effect class because it's not modifying any attributes on the owning player, but it does have delayed damage. So it deals some impact damage, which is set up very similar to the armor piercing, where it just has the generic weapon damage and it deals 10 damage on impact. But then it also has delayed damage, which will deal 30 damage using the gameplay effect weapon explosion. And right now, the weapon explosion gameplay effect basically just has a gameplay queue. Yeah, so it uses the same damage calculation, but it has a gameplay queue for explosion, which will play those explosion effects. Let's see. So then if I take a look at the incendiary, so this one also has a delayed damage config. So this one's a little bit different. It deals damage over time. So it's dealing 1 damage per tick. And if we take a look at this secondary ability or secondary damage, it's a little more complicated. So this one has duration, which indicates that it is dealing damage over time. And it also, you can see down here, this is where we set how many times it can stack. So this one can stack up to 3 times. But it is using the same damage calculation. So we can kind of reuse that. Go ahead and close this. So then if I head over to the rocket launcher, for example, the rocket launcher only has one ammo type right now, but it's set up a little bit differently. So we have no delayed damage, but we do have impact damage. So this is dealing, right now it's just dealing 20 damage on impact using the same weapon damage calculation. But this one actually has explosion settings set. So explosive is checked to true. So this means that this ammo type will deal damage in an area of effect. So it deals damage within a sphere to any targets that are within that radius. And the explosion radius is set right here, so it's set to 200. And we can also configure this to apply rocket jump. So this is where we can set this explosion to apply rocket jump to the player who fires the projectile. And this also has some FX settings set. So we have the VFX, surface to VFX. So in this case, this is just default. So it will play this rocket launcher explosion against any surface. But if we wanted to, we could set up some more so it would have different impact effects based on whether it hit skin or rock or some other surface. And the same thing goes for the sound, so the impact sound. So right now we just play the explosion sound all the time by default, but there are other, we could set different sounds if we so desired. So that pretty much covers it. I just wanted to give a little update and overview of what I've been working on. It's much easier to send someone a video than it is to send them to GitHub and expect them to download the project and try it out themselves. So thanks for sticking around this long, and hopefully I'll see you in the next one.